Hello guys, and welcome back to another video. Today I will be telling you how much time it would take you to vaporize water by stirring it. So if the water is not too much hotter than the temperature of the environment, then deforming it would most likely increase its temperature. This is because you are giving the water molecules energy, and causing them to move around rapidly. So let's assume that you are shaking the water side to side at a rate of 4 times per second, at a speed of 5 miles per hour before reversing directions, and that some of the energy you put to cause this movement is converted into heat and is absorbed by the water. Also, let's assume that the water will not radiate any of the heat away. So first of all, the amount of energy the water would absorb would change depending on how full the water's container is. The less full the container is, the more room there would be for the water to move, and thus create heat. Let's assume that the amount of energy absorbed is 0.5. In order to find the change in energy, we can use this equation. Change in energy is equal to the mass of water times the heat capacity of water times the change in temperature. Meanwhile, the change in energy is also equal to the number of shakes times the energy absorbed by each shake times the mass of the water times the change in velocity squared. If n represents the number of shakes, we can rearrange this equation to be n equals 2 times the water's heat capacity times the change in temperature divided by energy absorbed by each shake times the change in velocity squared. Let's assume that the water was first 20 degrees Celsius, or room temperature, and we are trying to get it to 100 degrees Celsius. This means that the change in temperature would be 80. Also, to make the equation simple, we have to convert the speed into meters per second, so 5 miles per hour is equal to about 2.2 meters per second. So, if the amount of energy absorbed is equal to 0.5, then the time would be equal to 2 times 4184 times joule per kilogram Boltzmann's constant times 38 times Boltzmann's constant divided by 0.5 times 4 seconds to the negative first times the value of 2 times 2.2 meters per second squared, or approximately 4 hours and 48 minutes. But of course, the water would probably radiate most of its heat away due to entropy. So it would probably take many more hours to reach 100 degrees Celsius. But anyways, hopefully this video helped you, and see you next time. Bye.